Good morning. In this video tutorial, we are going to learn about insertion sorting technique. So already we discussed about bubble sorting technique. Bubble sorting is a simple sorting technique. It compares the adjacent elements. Okay. In this insertion sorting algorithm, it's a different technique compared to bubble sorting technique. It is somewhat different. So we are going to learn the sorting technique in this tutorial. It's a simple sorting algorithm that works the way we sort when we play cards. You're all familiar with playing cards, right? When you are playing cards, if you are drawing one card, if you try to place those card means you will put it in some order, right? So you will insert in between a card, or you will insert a card after the number. For example, you are drawing number 4 card, so you will insert after 3 or before 5. Likewise, in some order you will insert. Okay, in that way this insertion sorting algorithm works. Okay, it builds the final sorted list one at a time. After each and every pass, so one item is sorted. Okay, so it builds the final sorted list one item at a time. Each and every pass it creates one sorted list. Okay, one item is sorted, and it is efficient for small data sets. It is not applicable for the larger list, and the time complexity of this insertion sorting technique is order of n square. And these are the steps involved in insertion sorting technique. So pick. So the terms are very important. If you understand the terms, it is very easy to understand the algorithm too. Step 1, pick. Pick the next element to be sorted. Okay, so already we are having a sorted list. So now in this particular pass, which element we are going to sort? Okay, we are going to pick the element. Okay, so that is called as key element. Okay, key element or the value to be sorted, that we have to pick. And the second step is you have to compare that element, picked element, okay, with all the elements in the already sorted sublist on the left hand side. So in our list, initially the first element is in the sorted sublist. Remaining n-1 elements are unsorted. Okay, and when you are moving to the next step, 2 elements are in the sorted sublist, that is on the left hand side, and third element is the picked element. So you have to compare that picked element with the already sorted elements. Okay, sorted sublist on the left hand side. Then you have to shift accordingly. So depending upon the value you are checking, so depending upon the elements in the sorted sublist, you have to shift the elements. The third step is shifting. Okay, so shifting all the elements in the sorted sublist that is greater than the value to be sorted. For example, I have picked the element as 5. In the sorted sublist, 7 is present. Now in that case, you have to shift 7 and you have to insert 5 before 7. So that is shifting operation. And the fourth step is after shifting, you have one free space, right? In that free space, you have to insert the element. Okay, so you have to insert the element in that particular position, in that particular free space. Okay, and repeat these steps until the list is sorted, until you have compared all the elements, until the entire list becomes the sorted sublist. So this is about the steps involved in insertion sorting algorithm. So the first step is picking, and the second step is comparing, and the third step is shifting, and the fourth step is inserting, and the fifth step is you have to repeat all these things. So this is about the insertion sorting algorithm. So these are the steps involved, and we'll see the algorithm and we'll see the working with one example. So algorithm insertion sort, it takes 2 arguments. One is array and the second argument is n. So n is the number of elements in an array. So first you have to declare all the variables needed for your algorithm. So here we have 2 counter variables. So one counter variable, it points the sorted list. Okay, sorted list on the left hand side, that is j. So j is a counter variable or iteration variable that is used for sorted sublist, and I is a counter variable that is used to traverse all the elements in the unsorted list. Okay, and key is the picked element. Okay, so which item we are going to compare. Okay, so that is the key item. Okay, so and the second step is we have to repeat the steps from first element to n minus 1. Consider our array starts by index 0. So initially 0th item, only one item. So that item is in the sorted sublist. Okay, and remaining items, so 1 to n minus 1, remaining elements are unsorted. So we have to sort all the elements. So for unsorted list, we are having the counter variable I. Okay, and we are picking the element, the next element. What is the next element? I is equal to 1. A of 1 is the next element we are going to sort. Already A of 0 is sorted. Okay, so key is equal to A of 1. Next time, after completing this pass, the key element is third element, fourth element. Likewise, it goes on. Okay, and j, so to which list we are going to point the j variable. So j variable is used to point the unsorted array. Unsorted array is before the picked element. Okay, so our picked element is ith element. So unsorted list is I minus 1 to 0. Okay, so j is equal to I minus 1. So you have to repeat the steps. You have to compare the key element with all the elements in the sorted list. So a sorted list starts from j equal to 0 till I minus 1. So reverse order, we are doing it in reverse order. So j is equal to I minus 1. You have to check j greater than or equal to 0 whether it reaches the first element or not. So in that case we have to stop. Okay, so sorted list is over. Meaning we have checked the condition. So j greater than or equal to 0 and a of j. Okay, so that sorted item is greater than the key value. So if a key value for picked element is smaller than the element in the sorted sublist, means we are going to shift. Okay, so what we are going to shift? We are going to shift the jth element to j plus 1th position. So a of j plus 1 is equal to a of j, and j we have to decrement because we are traversing the sorted list in the reverse order. Back landa poite irukum. Okay, suppose j is equal to j minus 1, and you have to check the condition again and again. Once the sorted list is over, the element is compared with all the elements in the sorted list, you have to stop the j loop, and you have to come out of the loop, and you have to exchange. Okay, you have to insert the element in the position at which the j loop stops. Okay, so set a of j plus 1. Okay, in that position we are inserting the element. Okay, inserting the item. Key is the item we are going to insert. Then these steps will be repeated, and finally we'll get the sorted list. Okay, so now we are going to see the working of this algorithm. If you see the working, you will understand the algorithm very clearly. I have written it on the board and I have pasted the pictures. Okay, so that you can it is easy for you to understand. See here, this is my array A with 5 elements. So n is equal to 5. So these are the elements present on my array. And the first element is 0 initially. Before doing any steps, so the first element, okay, so the first element is in the sorted sublist. You can see the element 9 is in the sorted sublist, and the remaining elements means from 1 to n minus 1. N minus 1 is 5 because our array index starts by 0. So these are the elements in the unsorted list. Okay, so one is sorted sublist and the another one is unsorted list. So from the unsorted list, we'll take element one by one, and we'll compare the element with the sorted list. Okay, and we'll exchange. If needed, we are going to shift and we are going to insert. Okay, so this is the operation involved in insertion sort. Okay, so first we are going to start with the algorithm by pass each pass. Okay, before moving to the passes, So we need to look into the parts of the algorithm. So unsorted list is 1 to n minus 1. Here n value is 5, so it is 4, up to 4. So outer loop, for outer loop we have used the variable I. For the inner loop, okay, for going through the elements in the sorted sublist, we are using the j loop, okay. So I loop eppadi pogum appadina, it starts from 1 to 4, j loop enadana I minus 1 to 0. Okay, so in that way we are traversing the sorted list as well as the unsorted list, okay. So j starts from 0. So j, if the j value is greater than or equal to 0, so this is the first pass. So if the j value is greater than 0, okay, what is I value? I value is 1. Then j value becomes 0. J is I minus 1. So we have to traverse in the backward manner. So j is 0. So j greater than or equal to 0. Condition true. And a of j. What is a of j? A of j means jth element. Okay, jth element means in the sorted list. So zeroth element is 9. So 9 is greater than the key value. Which value we are checking? 7. So 9 is greater than 7. So we need shifting. So it shifts all the elements. Okay. So likewise it will check the sorted sublist and shifts the elements. So after shifting, you can see after shifting and insertion, you can see our array looks like this. Okay, so 7 and 9. 9 is shifted and 7 is inserted in the position. Okay, so now these two elements 7 and 9 are in the sorted list and 3, 6 and 2 are in the unsorted list. Likewise, your algorithm, insertion sorting algorithm will work. Okay, so we'll see step by step. Okay. So already I told you I is a counter variable. It is used for outer loop. Outer loop denotes unsorted list. Okay, counter variable for unsorted list. And j is a counter variable. It is for the sorted list. And key is the picked element. So which element we are going to compare now with the sorted list. Okay. So initially list contains only one element in the sorted list. Okay, so our I loop starts from 1 to 4 if the value of I is 1. Okay, so what is the key element we are going to compare with the elements in the sorted list? So key value is equal to a of 1. So what is a of 1 here? 7. Okay, 7 is the element we are going to compare with the sorted list. Okay, so now we are going to take the sorted list. Okay, so sorted list starts from I minus 1 I minus 1 to 0. Okay, so here I value is 1, so I minus 1 is 0. Okay, so j is equal to 0. We have to check the condition j greater than or equal to 0. It means a greater than or equal to 0 and check pandrom. The first item starts by the index 0. Suppose 0 ku munadi edha element irukumo, so no element. So that's why we are checking this condition j greater than or equal to 0. Then the next condition is that element is greater than the key element. Okay, so the element in the sorted list, what is the element in the sorted list? A of j. A of j is greater than key. So a of j is 9. If 9 is greater than 7, okay, if both the conditions are true, you can see the AND operator. Okay, it means if both the conditions are true, okay, so what we are going to do, we have to shift. Either shift panano, so sorted list item we have to shift. Okay, எந்த item நான் check பண்ணிட்டு இருக்கோம் நம்ம jth item. அப்போ jth item should be moved to which position? J plus 1 position. Okay, so that is the thing. J plus 1 is equal to a of j. So what is j plus 1? J is 0. But 0 plus 1 is 1. So we are shifting the element from 0th position to first position. Okay, so 0th position element 9 is shifted to a of 1th position. Okay, and j is decremented. So now j becomes minus 1. When it checks the condition j greater than or equal to 0, condition false. So we can stop here. It means we have checked all the elements in the sorted list with the key element. Okay, that is the meaning. Okay, so after comparing the element with all the elements in the sorted list, so now we are going to insert the element. Okay, shifting nadandirukku appadina nama enna pananum, we have to insert the element. In the element, a key element we have to insert. In which position we have to insert? In j plus 1th position, because j is decremented to minus 1, illa the false condition. So you have to increment the j value. So a of j plus 1, it is a of 0. A of 0 is equal to key. What is the key element? 7 is the key element. So that 7 is inserted in the position a of 0. So now after pass 1, so your array looks like this. A of 0, in 0th position 7 will be there, and in first position 9 will be there. So after completing pass 1, so which two elements are in sorted list? 7 and 9 are in the sorted list, and remaining 3 elements are in the unsorted list. So now we are moving to the second position element. I is equal to 2. I is equal to 2 means third element. So the picked element is third element. So the next element to be sorted. Which element we are going to sort now? Number 3. So 3 we are going to compare with all the elements in the sorted list. Okay, 9 and 7, and we are going to shift and we are going to insert those elements. Okay, so now I is 2. So what is the j value? J value is I minus 1. I inrathu 2 unsorted list apna sorted list enga irukum? I minus 1. Okay, so from I minus 1 sorted list starts. Okay, adoda ending 0 to I minus 1. We are moving in reverse order. So j is equal to 1. So 1 greater than or equal to 0 condition true, and you have to check the condition if that element is greater than the key element. So 9 is the element in that position. So 9 greater than 3, condition true. If both the conditions are true, what we have to do? We have to shift. Which shift enna panano? 9 enna panano? 9 to be shifted to which position? Ipa current in the position la j value irukku, and the position next position ku shift panano. Okay, so a of j plus 1 is equal to a of j. Now the j value is 1. A of 2 is equal to a of 1 is equal to 9. Okay, so the 9 is shifted to next position. Okay, so j and the j plus 1th position we are shifting. Okay, then you have to decrement the j loop. Okay, why we are decrementing? We are going to check the next element in the sorted list. Okay, previous element. Okay, so j is equal to 0. J becomes 0. 1 la irundhu reduce aagi j becomes 0. 0 greater than or equal to 0, condition true, and we are checking the element with the key element. Again 7 is greater than 3. The sorted list element is greater than the key element, so we have to shift. Okay, so from jth position to j plus 1th position we have to shift. Okay, appo 7 enga move pandrom? From 0 to first position. So a of j plus 1 is equal to a of j. So a of 1 is equal to a of 0. In a of 0 7 is present, so 7 is stored in a of 1th position, and j is decremented. So when j is decremented, it becomes minus 1. So minus 1 greater than or equal to 0, condition false, so it comes out of the j loop, and in the next position the key value will be placed. Okay, so a of j plus 1, because for false conditions we have decremented la innoru decrement nadandirukku, that's why we are incrementing the j value. So a of j plus 1 is equal to a of 0 la. Now j value is minus 1, so minus 1 plus 1, it is 0. So a of 0 is equal to key. What is the key value? 3. So 3 is placed in that free position. 3 is inserted in that position, and the next and the elements already present in the sorted list are shifted. 7 and 9 are shifted, and new element is inserted in the position. Now in the sorted list we are having 3 elements, 3, 7 and 9. Likewise the other passes will go on. I equal to 3. Fourth element is compared with all 3 elements in the sorted list. You can see fourth element is compared with the elements in the sorted list. Sorted list contains 9, 7 and 6. What is the position of 6 here? 6 enga insert ahum after 3. Appa we have to do 2 shifting. 9 shift panano, then you have to shift 7. Okay, then you have to insert 6 in that position. After shifting 2 elements, you have to insert 6 in that position. The same procedure is repeated for I equal to 3. Then after this pass, your list, a sorted list contains 4 elements, so 3, 6, 7 and 9, and the next element is 2. Okay, I is equal to 4, so this is the 4th indexed element. So that element is checked with all the elements in the sorted list. So all elements in the sorted list are greater than this key element, so everything is shifted. 3 is shifted to first position, 6 is shifted to second position, 7 is shifted to third position, and 9 is shifted to fourth position. Then 2 will be inserted in the 0th position. So this is how the insertion sort does the sorting. So after completing all the passes, your final sorted list looks like this. Okay, you will get the final sorted list 2, 3, 6, 7 and 9. Okay, and when we talk about time complexity, when the I value is 1, when you're checking the second element, how many comparisons we have to do? We have to do 1 comparison. Maximum we have to do 1 comparison. If the I is equal to 2, 2 comparisons. If I is equal to n minus 1, n minus 1 comparisons. Okay. So according to comparisons wise, so 1 plus 2 plus etc. up to n minus 1 comparison. It depends upon n value. 5 elements irukku appadina 1 plus 2 plus 3 plus 4. Each and every pass it has different number of comparison. First pass la 1 comparison, second pass la 2 comparison. Likewise it goes on. Appo in general we can say in n minus 1th pass, so n minus 1 comparisons. Okay, so we know the formula, right? Sum of first n natural numbers 1 plus 2 etc. up to n, n into n minus 1 by 2, that is the formula. And this value is somewhat approximately it is equal to n into n minus 1 by 2. When you extract or when you expand the equation, n squared by 2 minus n by 2. So n squared, the coefficient of n squared is 1 by 2 and coefficient of n is 1 by 2. When you take the maximum factor, so the maximum factor pathana it is n squared. We'll discard all the coefficients. Coefficients discard pannuvom, and the factor mattum will take. So here the highest factor is n squared. So the time complexity of this algorithm is order of n squared. It is similar to bubble sorting technique. Bubble sorting technique time complexity is also order of n squared. Okay, are you able to understand insertion sorting technique? You play this video again and again. If you didn't understand this technique, it is a very easy technique. Okay, so these are the steps. The element is picked from the unsorted list, and that element is compared with all the elements in the sorted sublist. Okay, and shifting is done. If the comparing element is less than the element in the sorted list, so we have to shift it. Okay, so after shifting, you have to insert the element in the position, then you have to repeat until the list is sorted. So this is about the steps. When you see the algorithm, you can understand. Okay, so this is about the example. So that's all about the insertion sorting technique. So after listening to this video tutorial, you try to do this practice this problem, okay, with the help of this tutorial. Sort the list of numbers given here with the help of insertion sorting technique on your notebook and post it on your classroom. Okay, so this is the work after completing after watching this video tutorial. Okay, thank you girls.